Bismillah Rahman Rahim. Assalamu alaikum and a very good morning. Today I'm going to do logistic regression analysis. Logistic regression analysis is a very important in epidemiological studies. Epidemiological studies are not complete if logistic regression is not done. So that much important logistic regression is. Last time I told you that there is an odd ratio and that is crude odd ratio that we calculate by WinPappy or other frequency analysis. So that is excellent really, but that is crude odd ratio. Log odd ratio is more authentic, more accurate and more acceptable in epidemiological results, study results. In logistic regression analysis, if we have noted various parameters like age, now age is in years. So age or body weight or other similar parameters, if you have recorded those parameters, now you can see whether with the 1 year increase in age, the chances of infection are increasing or decreasing and they are statistically related or not. Or there is an association between that very parameter like age, or there is no association of age with occurrence of a disease. So it gives a real picture. Last time we made certain groups on the basis of age or weight. But here the actual weight or actual age is used. This way this is more authentic, more accurate and gives us a better picture whether there is an association between age or weight or parameters like this with the occurrence of disease or not. So that way epidemiological studies are incomplete if logistic regression is not done. This is why it is very important, and I hope we will understand it. It's very easy and we will understand it very well. So let's start it. So for logistic regression analysis, I'm going to use another data that is again an epidemiological study data. So this study was conducted on cattle and buffalo at 4 livestock farms. The actual age of the animal was recorded, the actual weight of the animal was recorded, that is there was data available at the farm in the register, so we used that data, and their milk production record was there, lactation length record was there, lactation number was there, so all the data was there, we recorded all that from their available register. And the study was conducted on tuberculosis. We used tuberculin test and various other tests. So the 0 is for negative animal and 1 is for the positive animal. Now we are going to do a limited regression analysis by using this SAS online system. So let's do it. We have to upload the data. This data is not here. How to upload the data? See once again. You need to click on the upload button here and then choose the file. And you need to look into where the file is. So click upload. After selection of the file, so I'm removing the already selected data file. So this is how it should appear normally when you log into the system. Here is that data file which I was showing you. We need to double click it. Now this has opened. Now this has opened, and you remember we need to click on the code in the edit section. So we clicked in the edit section and now we have to do data analysis. So I'll be doing a logistic regression analysis. First, I will include all the variable and I will select the backward elimination procedure, the command for that, and see among all the variables, which variables are significantly associated with occurrence of disease. So this is what we are going to see in the first instance. So let's do it. So we need to sort first. We need to sort the data by species because there is buffalo and cattle, then form, then breed, and then the result. Okay, so we need to sort this data, and then we need to give the other command. So this is a proc sort data work import. This is the data file, and we are going to sort it by species. That is cattle or buffalo, farm, breed, and results. So this is how we are going to sort the data. And then we will apply the proc logistic data import, this import file. You can add a work import, descending. This is important whether we want to see the ascending results or descending. Generally, the descending command is written. It may be written complete. So like here, you can just click it and it's there. Or you can just write the abbreviation. That is enough, okay? And our model is a result. Now we need to add species, age, weight as they are written in the same way. They will be selected in the same way. Okay, we write everything from, we copy everything from here, then we will be doing some editing. So we need to look into whether the species has significant association or breed has significant association. This animal, we need to, animal, its identity, that is not needed. Age, weight, weight group is not needed. Lactation length, this grouping is not needed. Lactation number, lactation length, milk production, status of the animal, total animal at the farm, total small ruminant and small ruminant, whether they were present on the farm or not, total cattle, and total buffalo, whether they are, and we need to put here this backslash selection, backward elimination procedure. This is backward selection is backward, and lag fit. Lag fit is a term used here to see whether our model is fit or not, our results are accurate or not, and then run. So this is how a logistic command is given. You can use, you can include one variable. I'll be doing other analysis. We can do logistic regression analysis by using various syntax. or various commands. This is the first command which we are going to use. We are including all the variables in the model, and then we have asked it to eliminate which are non-significant from the model and gives us results which are only significantly associated with the occurrence of disease. So that is what we are going to see. Now, here the results are displayed. So it is saying all effects have been removed from the model. That indicate that none of the parameter was significantly associated with the occurrence of disease. Okay, so none of the parameter was significantly associated with the occurrence of disease. So all the effects were, you can see effect of weight is removed, effect of lactation length is removed. So and at the end it is written all effects have been removed from the model. So none of the variable was associated with the occurrence of the disease. Now let us see another thing. Now we want to see, we are going to add bivariable species, that we want to see whether the occurrence of the disease in buffalo and in cattle was associated with any of the variable or not. So from here, from the model, we have removed the word species. We have only added in the bivariable the species. Now the results will be displayed for cattle separately and for buffalo separately, and see if there was significant association or not. So here is species 1, results for species 1. So you see various effects are removed, and we want to see the last table if there is any significant association. So for species 1, it is showing that only the weight variable was significantly associated with the occurrence of the disease. No other variable, they are all shown here, they were not associated with the occurrence of the disease, only or presence of disease. With the disease, if it was present, and it is. So we will complete this table, and let's see for the, now this is the odd ratio, point estimate, this is the odd ratio, 1.013. This is the odd ratio, log odd ratio. And let's see for species 2. For species 2, no variable was significantly associated with occurrence of disease. All the variables, they show non-significant difference. You can see the probability values here, and there is nothing shown below. Let us do another analysis. Now you can include single variable at a time. So we use the command result. Result is our outcome variable. It may be anything. That is our outcome variable, and breed and lag fit. This is how the command is used in the model, and we are analyzing by species, that whether give us the results in cattle and buffalo separately. So we ask it to run, and it has given the results. So for species 1, now species 1 is cattle and species 2 is buffalo. You can see here the nodes are present in the Excel sheet. Everything is written here in the Excel sheet.
This was the data which we used. And for species 1, the chi-square value or the p-value is non-significant for breed. Okay, so that indicates there is non-significant difference or non-significant or no association observed for breed in cattle. There was only one breed in buffalo, so that is immaterial for buffalo. So only one breed, that was Neeli Ravi buffalo. So no data is shown for species 2, that was the buffalo. Only for cattle there were different breeds for cattle present. So it has shown that breed was non-significantly associated with the disease. Now, same way we can do for other parameters, for age. It gives us the results for age. So you can see here the p-value is non-significant for species 1. Here is species 1. And for species 2, again there is a non-significant association. So our backward elimination procedure showed the same results. So you can do this analysis for any, it will be non-significant because our backward elimination procedure, when we included all the variables, it showed non-significant results. So, so this is how logistic regression analysis is done. Okay, one more thing. There may be, age may be a confounding factor. So if age is a confounder, well, let's see whether the lactation length is associated with the occurrence of, or lactation number is associated with the occurrence of disease or not. So we need to copy this lactation length. Controlling for age, let's see lactation length has significant association with the disease or not. For species 1. So you can see the p-value here. So after controlling for age, the lactation length was non-significantly associated for species 1. And same is for species 2. So there was no association found between lactation length and presence of disease in cattle or buffalo in both cases. So this is, here we control the age. This is how we control the age. Now lag fit, the results for lag fit, they are also very important. So here is the Hosmer and Lamichaud goodness of fit test results, probability non-significant. So it means our model is fit. So this is how we do logistic regression analysis. After controlling for one parameter, you can add age and breed. After controlling for age and breed, whether lactation length was significantly associated with the occurrence of disease in cattle or buffalo or not. So you can include another variable, or it can be sex even, or any other parameter you can include. It all depends upon your data. So after controlling for age and breed, lactation length was non-significantly associated. For species 1, and for species 2, the breed is actually only one breed, so it does not show, even then lactation length is non-significantly associated. So our model is fit. It's a non-significant Hosmer and Lamichaud goodness of fit test. So this is how we do logistic regression analysis. Well, I've touched very basic type of logistic regression analysis, but I hope I covered three various angles. One is including all variables, and backward elimination procedure was used for model one. And second, I used the results and individual variable age or weight, or you can do individual variable, and then after controlling for one parameter, one variable, whether the other variable were associated with the disease or not, because the controlling for one variable mean we are eliminating effect of that variable. It may be an age. TB in animals, their chances of occurrence of TB is more in the older animals. So we have eliminated that age effect, and we have tried to see whether lactation length was associated with tuberculosis or not. So it was not. Anyway, these are what the results showed us. Anyway, so this is how you can apply logistic regression analysis for your data. This is one of my student data which I used it here. So I hope everything is very clear.
I do hope we have understood how logistic regression is applied in SAS, how the model, first we need to sort the data, and then we need to apply a logistic regression model, how that model is built. So I have included all the variables and used the term by backward elimination procedure. So all the effects that were non-significant, they will be eliminated, and they were eliminated, and only the significant factor which was associated was left. In fact, there was no association found, so all the effects were eliminated. So it all depends upon your data. So this is one of my students' data. He conducted this study. Your data may be different, and you may find significant association. But I there was one significant association that was of weight in one species when we used bivariable species, because we had the data of cattle and buffalo. Then we analyzed the data including the species as bivariable to see the effect for cattle separately and buffalo separately. And then we used the model result equal to age or weight or lactation length or single parameter, single variable, and // fit : and we run the command and results were shown. And then the third is we can include confounding factor at number 1 and the comparing factor at number 2. So then you can add 2 confounding factors and add our third factor which you want to see whether that has a significant association or not. So that way you can do this data analysis. The model is there, you can see it, and you can record and make your notes, and you can use for your data for analysis. Thank you very much. See you next time. Allah Hafiz. Goodbye.